scientific notation. In scientific notation, the number is written as y times 10 to the x, where y is a number between 1 and 10 and x is a positive or negative exponent. For example, 1.5 times 10 to the 6th. Is that the number written in the scientific notation? Yes, because here this number is between 1 and 10 and this exponent is positive. Now, for example, is this number a scientific number? No, we call this as a standard form, but then you need to know how to change this into the scientific notation. If you cannot see the decimal in the number, then where is the decimal? It's at the end. To make it or convert to a scientific notation, your decimal should be 1, 2, 3, in between 2.5, in between 2 and 5, I'm sorry, because that will make it as 2. If it is 2.500, then this number, which is y, is between 1 and 10. So, since you move the decimal 3 places backward, then the exponent here will be positive and it will be 3 because we moved the decimal 3 places backward. On the other hand, let's say if we have number like this and we want to change it to the scientific notation, where do we want our decimal to be? Between 4 and 5, because between 4 and 5 it will make it as 4.5, which is between 1 and 10. So the point is the decimal should be after the first non-zero number, and the first non-zero number is here. So you're moving decimal 3 places in the forward direction. So that will make it as 4.50 times 10 to the negative third. So this is going from standard to scientific, and similarly you need to know how to go from the scientific to standard. For example, let's say 1.575 times 10 to the third. Is that a scientific notation? Yes, because this number, again which is y, is between 1 and 10. Now to change it into the standard, what we're going to do, since our exponent is 3, we move the decimal 3 places in a forward direction. So that will be, now decimal will be here. So 1575 will be the answer. Similarly, let's say you have this, but this time the exponent is negative. Then in that case, what do? Here is a decimal. Decimal you need to move to 3 places backward. So backward means, so what will be here is going to be the 0. So 0.001575. Now there are three. What is temperature? Temperature is that measures how hot or cold the object is. There are main 3 units of temperature: degree Fahrenheit, degree Celsius, and Kelvin. Given the temperature in one unit, you should be able to find it in the other one. For example, let's say the temperature is 20 degrees Celsius. What's the temperature in degree Fahrenheit? So we use the first equation, 1.8 times degree Celsius plus 32. So 1.8, you replace degree Celsius with 20 plus 32. And what is 1.8 times 20? It is 36 plus 32, which is equal to 68 degree Fahrenheit. The next is the density. And what is a density? Density, it's a physical quantity or it's a physical property that relates mass of a substance with its volume. And its formula is density equals to mass by volume. Now this density, so another way of saying is if you have a less dense substance that flows on the top of a more dense substance. For example, density of water at 4 degrees Celsius is 1 gram per ml, while density of ice is 0.92 grams per, I'm going to say grams per cc because it's solid. So which one has the less density? The ice has the less density. That's why you see the ice floats on the water. Now, since this density, you can see there is D, density, mass, volume. Given the values of any two, you should be able to find the third one. For example, let's take a problem. What is the density of a substance if the mass is 10 grams and the volume displaced by that substance is 2 ml? So let's say I'm going to put 2.0 ml. So what is density? Density is mass by volume. Mass is 10 grams. Volume is 2.0 ml. What is 10 divided by 2? 10 divided by 2 is 5. Now, again, keep in mind the significant figures. 10 has only one significant figure. The 0 is not significant because there is no decimal. So one significant figure in 10, two significant figures in 2.0 because this 0 is significant because there is a decimal. And we go by the fewer. So that means the answer should have only 1. So the answer will be 5 grams per ml. Now here in this problem, given the mass and the volume, you were told to find out the density. Similarly, what if mass and density are given to you and you have to find out volume? Remember, density is mass per unit volume, which will make volume equals to mass over density. Also, what if volume and density are given to you and you have to find out mass? So that will be, mass will be density times volume. The next thing that you need to know is the difference between density and specific gravity. Now, specific gravity is a unitless, this is very important, it's a unitless quantity that compares the density of a substance with the density of water. So since it's a ratio of two densities, that's why it's unitless. And we are comparing it with the density of water, and since the density of water is 1 gram per ml at 4 degrees Celsius, that means the specific gravity of a substance will be equal its density, but it contains no unit. Let me take a problem, and for example, let's say if the density of a liquid is 0.80 gram per ml, then what is its specific gravity? Remember, specific gravity is density of a liquid, which is 0.80 gram per ml, divided by density of water, which is 1.0 gram per ml. This unit cancels with this. What is left? 0.80. So that's what was explained here, that the specific gravity of a substance equals its density but contains no unit.
Made with Doodlecast Pro.